Hello students, welcome back. Let us complete problem 4. Excuse me, did I say complete? No. I'm not completing anything actually. This is just hint. So I'll just give appropriate hint. I'm not going to complete anything here. Okay, let's go. First method is critical value method. Basically what we want to do is to get the normal picture and then get appropriate center, of course, and then compare this critical value, which we'll have to calculate, with the observed difference of 7.5 percent point, 0.075. Let's see, 0.652 minus 0.577, and this is the observed difference, 0.075. And we are going to compare this with the critical value. Ready? Okay, here we go. Standard error we already calculated. Here's the initial picture. Outline, center, end, and then finally shade. Center is 0 as usual. We are doing two sample inference, so default is no difference. So difference is 0. And then where do I put end? Good question. That's going to be the threshold associated to this alpha value. 5% here, highlighted in red, and then 95% here in blue. Now I'm using two colors, so I can do blue and red. If you're using just pencil, then this part will be just white, and this will be dark place. All right, let's find out x2, the end. How do you do that? Z-score is end minus center over SE. Let's expand the font. And that is approximately equal to the end x2 value looking at. Center, as always, it is 0. Nearly always, excuse me, I have to say. And then SE is a value you calculated in problem 3A. You did it already here. And then that has to be approximately equal to appropriate z-score. What is that something when you have this z-table here? I'll give you just one hint and then just move on. Look at the shading. Look at this picture, shaded in the left. Here I have shading in the right. They're not the same. Okay, let's go. Shading in the left, but here I have shading in the right. Here I'm using two colors, so blue and red, but if you're just one shading, if you're using pencil, then this part, right hand side part, the wing part is going to be the shaded part, and this will be the white part, okay? Please visualize your own drawing. So these two are different. So number you find over here, they're not going to be the same thing as you're going to find here. So you have to do something. You have to do 1 minus something. Okay, all right. Either you do 1 minus something or change the sign or whatever. Okay, I'll stop here. I'm giving away too much. Reading the table and then getting appropriate z-score here is something you should have mastered by this time. So I'll stop there and compare, and then you're going to get something. And by the way, just conclusion, and that's about it. It'll turn out, if you do your calculation correctly, the threshold, the critical value, will turn out to be about 11% point, 0.11 something. The observed difference, on the other hand, is about 0.075, excuse me, 7.5% point. So as you can see in the picture, close to the null, so null wins. So 0.075 versus 0.11. So if you use this critical value method, then the conclusion easily follows. That's the advantage. Do we have time for probability value method in this video? No, let's not do that. Don't do that. I'll just stop here and I'll explain probability value method in a separate video.